Welcome back to statistics class. Today is a pivotal lesson. We are going from talking about the branch in statistics known as descriptive, and we're going to switch over to the other branch of statistics called inferential. So just a quick review, because I know we haven't talked about this since the beginning of the class. Descriptive statistics is the study of how to summarize or describe or organize the data that we've already collected, like finding averages, finding standard deviations, organizing the data in charts and graphs. But today we're going to step into inferential statistics. And inferential statistics is the branch of statistics where we go beyond just describing the data. We're actually going to make educated guesses, predictions, estimations, and apply it to the entire population. And this is very important, especially when it's not realistic to measure everyone or everything. So there are several methods that we're going to look at when we're discussing inferential statistics. And the first one we're going to look at is called confidence intervals. And this is a way to make estimations about the population parameter, whether it's a population mean or a population proportion. So a confidence interval is a range of values that's based on sample data that we believe that contains the true population parameter. And so we want to think of it in a way as to estimate an unknown value, but we have what's called confidence levels. And that confidence level dictates how wide the range of values are. So of course, if the range of values is more wide, the confidence level goes up. And if the range of values is smaller, then the confidence level goes down because there's less of a chance of it lying on that interval. This interval gives us room to account for sampling variability and the natural differences that we expect when we work with samples, okay? And this is relying on the central limit theorem as well. So let's first talk about the parts of this interval that are key to understanding how this is built. Let's see, we have a point estimate, and the point estimate is going to be the center, which is going to be the sample statistic. So the point estimate is the sample statistic. Whether it's the sample mean or the sample proportion. So that's what goes in the middle. That we're using the sample mean or proportion to make our educated guess. And then we have what's called a margin of error, and that tells us how wide the interval comes out, and that's based on our confidence level. So the margin of error is the distance that we come out in either direction to create the lower bound and to create the upper bound of that interval, which will give us our range of values. Now, the confidence level dictates how far out that margin of error comes. If the margin of error, or I should say, if the confidence level is bigger, then the margin of error is going to get bigger, so it increases that interval. If the confidence level is smaller, then the margin of error is going to get smaller because the distance of that interval is going to get smaller. So once we have our point estimate from the sample, then we add the error, and that will give us the upper bound. Then we subtract the error from the point estimate to get the lower bound, and that gives us this whole entire interval from here to here, which is our range of values. Let's look at example 1. JetBlue conducted a study on passenger satisfaction with new reclining seats. They measured the comfort on a 10-point scale, After surveying 36 passengers, a 97% confidence interval for the mean comfort rating was 6.8 to 8.2. This is what's known as interval notation if you haven't seen it before. The number on the left is your lower bound, and the number on your right is your upper bound. The question is asking us to find the point estimate for this confidence interval. Now remember, the point estimate is that value in the middle that we get from the sample. So if we look at this on a number line, here's my lower bound of 6.8. Here's my upper bound of 8.2. My point estimate should be in the middle. And because we're talking about averaging here, the scores of this 10-point scale, this point estimate in this case is considered the sample mean, which is our X bar. So our point estimate is in the middle. We need to find the value in the middle. Now, if you recall, we know how to find the midpoint between two numbers. We did that when we talked about frequency charts, and we needed to find the midpoint. To find the center between 6.8 and 8.2, we take 6.8, the lower bound, we add it to the upper bound, and then we divide by 2. That will give us our midpoint. So when we work that out, when we take 6.8 plus 8.2 and take that sum and divide it by 2, we get 7.5. So that's going to be the center of our confidence interval. So 7.5 is our point estimate.